Well, good afternoon. We're starting to make our way into the later hours on East Coast. Hope everybody's been having a great day today. If you were joining us after our COVID-19 discussion, for those of you watching later, you can go back and find that on practicalshowtech.com in our archive section. This discussion is taking us, as I did a post on LinkedIn around this one saying, hey, we've been behind our racks. We've been dealing with RF. We've been dealing with comm. We've been dealing with all this stuff behind the scenes. Let's move out front and put ourselves in the position of the audience listening. And I made sure, everybody's like, we're not going to be doing shows forever, right? Come on, we will. We aren't this week. We're not probably going to be doing them next week. But at some point, we're going to be returning to that. The integrators, they're continuing to work. And the new facilities are going to continue to come online. And the idea of being creative doesn't stop when COVID's around. Just because you have to shelter in place, all the more reason to get creative and to think creatively and think about technologies that, yeah, maybe we're not actively using, maybe some of us are. When this whole thing started, a friend of mine reached out to me and said, hey, what do you think about this topic? And I was like, you know what? I think that's a really cool idea. The idea of immersive audio and live sound. We hear immersive audio and it sometimes can become very much a catchphrase, right? But there's a lot of delineations because, you have immersive audio around AR or VR. You have immersive audio in the broadcast world. And then we have immersive audio in what I'll consider this live event space. And that's what we're talking about today is how do we bring this to an audience? There will be audiences in our rooms. This isn't forever, just as we discussed before. This is a blip in a moment of time when you keep zooming out. So I'm going to keep preparing. I'm going to keep coming up with ideas and thinking about that. So to that end, today our discussion is with Nick and Zach from D&B here in the US, trying to take us through kind of how do we think about immersive. When we were talking about this a couple weeks ago, it was like, this can be such a broad topic, but at the same time, there's a lot of very logical places. So I think you'll enjoy today's presentation. In your handouts, you're going to find a web link. Nick and team pulled together in one place all the downloads, array calcs, as well as a lot of the slides you'll be seeing today. Go there, grab that information. As we always suggest, interact with our presenters. Pete, Mac, let's talk a little about the Q&A. We'd had our slide up, maybe throw our slide up again real quick with the support email for D&B, because I think a lot of ideas are going to be coming in. So take it away.
Sure. Well, I'm sure many of you have been through this routine with us before and understand the Q&A process. But for those of you who don't, in the GoToWebinar control panel, which will be today, it's on the left side of my screen. The last time was on the right. There will be a little pull down that says questions. At the bottom of that, you can type in your questions. Your questions will be seen by us, by the panelists, and by the organizers. They won't be generally be seen by each other. But we will see them, and we will try to get as many of your questions answered as we can. We may not get to all of them. There are very often many, many questions, but we'll certainly try to get to every topic and get as much of your questions answered as possible. Pete?
Yeah, we'll be taking a couple of breaks for Q&A throughout the presentation.
Oh, great, great.
Terrific.
And we will be, if we see a question that we think should be addressed immediately, we'll pop back up on the screen and let you know.
Absolutely, we're casual, and this is all about
Exactly.
the attendees. So the more interaction we get, the better.
I got all dressed up for the occasion.
I've done immersive audio for about 10 years now, but I do it for intercom. Very, very regularly. For at least for me, I want to have all the conferences come over here, party lines come over here, the director come out of a speaker behind me, because it's the spatial ability of listening, particularly if you have to listen to a dozen different channels at the same time, totally
If
cleans it up.
if this was Zoom and I could put up a virtual background, I have some shots of the one immersive audio show I did at AT&T Bell, or no, Nokia Bell Labs now.
Oh, that was a nice one. That was a nice one.
Chamber orchestra in the anechoic chamber, and the audience in an immersive audio room with 64 Genelec 8020s.
Nice.
Yeah,
And
I mean,
so,
Peter, your example of being able to demask using, the world's best microphones and the
huge.
world's best signal
Huge.
processor.
Right.
Huge. And that's so much of what we're going to talk about is this idea of re-enabling the audience to use
Yeah.
their head-related transfer function.
Even for in-ear monitors, typically monitor engineers for years have set the stereo image between them, but now they're setting the stereo image front and back.
Right, with Clang, they're going wild.
With devices in their console, which is amazing.
Right.
So Nick, why don't you go take it away?
All right, you got it. Thanks, gentlemen. So, as an introduction, Zach and I are here with you today. We're both on the support team for D&B Audiotechnik, based in Asheville, North Carolina, which is the headquarters for the Americas of D&B. We are both sound engineers by trade, working in the live arena most. And these days we do support, which involves both proactive support, things like these webinars or in-house trainings at our facilities or at a user's facility, and reactive support, things like double checking system designs if a user wants a second opinion, or heaven forbid, the hair on fire on a show site, help bail me out of this problem I'm having type of support. So yeah, you ready, Zach? You ready to do it?
Yeah, I think so.
All right.
So just to kind of give you guys an idea, anytime I sit and absorb and listen to any kind of information, I like to kind of have a roadmap of where I'm going. What are we going to talk about? The first kind of section would be just the status quo. What are we currently doing with PA systems? What are the challenges that we all face, whether we think about them every day or we don't necessarily, and kind of what we see as the future of live sound and how PAs will be different in the future. And we'll kind of break that up into a couple different sections, and then some case studies of kind of how this has been done in the wild, and not from the what I like to call trade magazine case study, which is look at this list of gear and look how awesome everyone did. Not like that, but really just kind of to give you the example and kind of get the wheels turning from a theoretical, hey, this is how this might work, or I could see this being a tool in my future toolbox to enable me to achieve some things that currently might be difficult to achieve. So that's kind of where we're going.
Yeah, and we have a link here at the bottom. That link is the same one provided in the handout that you might see a link for in the chat feed. This is basically just a list of documents, some kind of technical supporting documents of what we're talking about, also an example file that can be opened in ArrayCalc and R1, 2 pieces of D&B software, which are available to download for free from the website, and some other materials in there as well. So feel free to take a picture, grab a screenshot of that link before we move off the slide. Okay.
Yeah, so to kind of get all on the same page, where did we come from, right? If you're in this webinar and you happen to have done this show, maybe this is you in the photo, we've been looking for you for years. But what did PA systems, where did we come from, right? It kind of started out as this sort of hodgepodge of components, right? Somebody made maybe a loudspeaker horn, and somebody made an equalizer, and there was a mixer and a crossover and an EQ and kind of all these components to make a system. And while we here at D&B now kind of we approach things as a system approach, that's kind of a standard to a degree in the rest of the industry as well. We've kind of come up with some unified standards of how we approach these things, but at the time, when PA systems were first being used for large scale performances, there was really no thought of imaging or translating exactly what's going on stage. It was more of like survival, right? Let's get what's going on stage. Let's just get it out as loud as we can, and maybe get it to where you can hear it, make it a little bit louder for the people in the back. So we kind of didn't really care about imaging or immersing people, as it were, at the time. We were just trying to get, relay information. We were just trying to scale up what was happening on the stage to a bigger audience. And kind of where we are now, let's think about that. We've kind of got a basic set of standards and kind of all agree on a general idea of our goal with public address systems, what we're trying to do with a PA, and kind of a uniform strategy of approaching it, where we kind of all, in general, base our PA deployments around a main system that's probably a left and right main system, or maybe it's a mono system, but a left and right main system, with then kind of trying to cover as many people with the main system as possible, then supplementing that system with whether it be outfills or delays, or in this photo here to the right, you've got a main system, an outfill system, then a 270-degree system, another hang just to cover, around the bowl, right? So the way we're kind of approaching it now is let's make the best compromises we can. Audio is always a series of compromises, right? So let's try to cover as many people as we can and give them the best experience that we can. And then those other areas of the venue that maybe aren't as optimal for viewing, or maybe aren't as close to what's happening on stage, we'll give them kind of the best we can, the best representation of that main experience that people are getting in the middle, which is obviously a way to do it. And it's far better than we would have done in the past, now that we kind of have a standard way of doing this. And when you walk into most arenas for a show or a ballroom or something, you're going to see, for the type of event, maybe 8 times, 7, 9 times out of 10, you might see the same similar type setup for those things. So we kind of agree on, we have this idea of how we're going to cover an audience, and it's all based off stereo. So if we think about just mono versus stereo, right? Mono being the most basic, we're just trying to amplify what's happening to our listener. And this obviously was, far and above what was happening before, which was no amplification. So, hey, great step here, right? But really kind of no thought for the level and time relationship that's happening in your head. No real spatial information can be achieved from just a single source. Now, the one benefit to this, you could say, is, well, hey, look, with a mono system, everybody kind of gets the same thing, right? Because it's the same for everybody. There's no, I'm this close to that close to this source, whatever. It's kind of the same thing. And then we went to stereo, and especially kind of when stereo came along in the recording world, all of a sudden this opened up all kinds of possibilities, because they were recording 2 channels of audio, and everyone, eventually had 2 channels of playback audio. So at first, people didn't really kind of know what to do with that, right? You listen to some older recordings, and it's like a floor tom way over here and one vocal over here, and it's kind of cool, unless you happen to be riding in the car listening to it. Then your passenger gets to hear that drum and you don't. But a much better approach. And there's a story that I love, that Brian Wilson from the Beach Boys, he was talking about stereo recordings, that they early Beach Boys stereo recordings, and he said that he didn't like to do a lot of the stuff in mono, and people thought that was because he was deaf in one ear, and really kind of what set him off is, he said one time he went to a grocery store, and he was in the bakery, and he heard a Beach Boys song come on, and he heard his voice. And then he went over to the butcher, and he heard his brother's voice over the butcher. So he was like, wait a minute, no more stereo. I don't know what the experience is going to be like, because however the supermarket was wired up, that was the left, that was the right, and nothing they were doing was translating. So, stereo, huge leap forward, right? And we all kind of have this base off of that, of, okay, this is what I'm used to hearing, because I am walking around with a stereo microphone system, the best one in the world, on my head. So let's think about that. Let's think about stereo and how it normally works in a space. So I have a slide here that kind of just shows the basic size of maybe your living room at home. So let's take your living room at home. Somehow the person you live with lets you put 2 giant speakers on the wall, and so, somehow, you know, you thought, hey, we don't need those windows, let's put some speakers up. So you put some speakers up, you got a stereo system, or maybe this is just your stereo, you know, home theater, whatever. So you got the system, right? And in a small space, this graphic is kind of to show you in scale where you're kind of sitting, how much spatial information. So how much you are getting both sources arriving at you in a way that you can translate spatial information between the two. So the panning actually makes sense, and when effects and things like that happen, or you know, things that are placed in a certain area, they make sense to you in this kind of white sweet spot. And this is great in your home living room. Maybe you've experienced this, right? Maybe you have a couch up against the back wall, and there's kind of the 2 good cushions in the middle. And if you're, you know, you kind of get to the couch and claim that spot first. But as you move one way or the other, you start to favor one of the sources, and you don't really get that same spatial imaging. So stereo, it might work okay, great in this, you know, let's say your living room scenario. Let's step this exact thing up to a large theater, right? So if we look at the same color scale here with a large stereo spread PA, what's kind of the things that stick out to you first? Well, obviously, depending on where you are, you know, if you're closer to the right side of the room, you're going to be imaging to that right speaker. But look at that sweet spot that we had in the other slide. Look at that kind of localization sweet spot. It's right in the middle between these 2 sources, and it's very skinny in relationship to the entire audience plane, and also it's probably in, you know, a large percentage of venues the middle aisle. So there might not even be anyone sitting there. So the sweetest spot for spatial information or making sense of a stereo mix is sitting right there where no one is actually even sitting. Now maybe you don't have a center aisle, so you say, oh, I do have a good, you know, nice strip of seats here in the venue I'm doing a show in. But in general, you can see the problem here. Stereo works well in a small space, or, you know, a really small space. That's not a joke about the size of my head, but what, you know, it's kind of like as we scale this up, we start to see an issue here of how does this translate into a large space. So as a mix engineer, you know, everyone's seen this slide before, right? The guy with the suck knob. Last day as the band's audio engineer, which, you know, I love it. If I had any tattoos, this would be the one I would get. But you know, it's kind of what, and maybe you're not an engineer, but wherever you sit in the audio signal chain, you are affected by these decisions that are having to be made at the console. So with a stereo system, we kind of end up, well, we would say mixing on a wire, right? So we're kind of forcing all this dynamic and spatial information down a small tube. So we kind of have to bring everything down together and do a stereo mix. So we end up doing a lot of demasking sources. So we've got this much sonic headroom, and we've got this much, you know, we've got a frequency response of our PA, and we're trying to kind of organize things in a way that complements each source the best. So we're carving out room for that, you know, for that drum to sit there, or that guitar part, or, you know, obviously the vocal. We're trying to get that right in its perfect spot. So we end up doing a lot of things. And maybe this is kind of how we became a good engineer, right? We're good at this. We're good at, you know, kind of using all of our tools available to us, be it through equalization and dynamic processing, all that stuff to make this happen. And we end up kind of carving out room for things in the mix is basically the main point I want to make there. And we're using, you know, plugins, all this hardware to kind of make that happen. And not only are we doing that with our mix, we are kind of doing also that same idea to our PA system, where we're requiring our loudspeakers to be able to have so much dynamic range and be able to reproduce so much out of, you know, these let's say two main sources, that we end up requiring a lot more headroom out of the PA, because every speaker is kind of getting the same load to bear. There's no dispersion of this energy across multiple systems. It's kind of, we're asking each component to do the whole mix, as it were, or the left portion of the mix, the right portion of the mix. I hope that kind of makes sense to you. And the other really kind of challenge we face is time alignment. And when I say time alignment, I don't just mean between two sources. Yeah, that's an issue, right? If we're deploying a sound system and we have any kind of delays or fills or anything like that, we have to time align those sources together. So at our listening position, they're not getting multiple arrivals, messing with not only their acoustic image, but their ability to even have any kind of intelligibility, which I think we would all kind of agree that's the whole point of a sound system, is to provide intelligibility, to transfer what's happening on stage in an intelligible way, no matter if that's a vocal for a corporate show or, any kind of musical event, or maybe something that is even wildly artistic in nature. We're trying to translate that in the most intelligible way possible. So if we're making time alignment decisions between sources, that's one thing, but there's also time aligning between acoustic sources. So I use this picture because I used to work in a lot of places that smelled like a club, because they were, right? Places like that where it's like you kind of walk in and you're like, they have live music here, I can smell it. In those type of places where maybe you have a band on stage and you've got really loud guitar amps or drums or whatever. And for me, when I was timing out my front fills, I used to actually just time align those fills to the guitar amps, because they were the loudest thing on stage. The people up front, that's what they kind of came to hear, right? They were really into that. And that's great. I could make a decision based on what I thought was the most important. But then that meant my timing was wrong for the drums, wrong for the vocal as far as the acoustic source, which really doesn't matter in a club because it's very small. But as far as I had to make a decision, I had to make a huge compromise as far as the alignment of my acoustic source and my amplified source, simply because I only had one place to do this, and that was for that speaker. My whole mix was going down that speaker. So it's a series of compromises. Also, the audio doesn't really match the visual, right, with what's happening on stage, simply because I'm hearing something over here, but I'm looking at someone here. And this is kind of one of those things that almost to a point we've kind of just all gotten used to. And it's once you listen to a spatial system that kind of addresses this problem, now it becomes incredibly frustrating and fatiguing to go back to that, because you actually recognize that listening fatigue that's occurring as a result of that distinct difference between your visual and what you're hearing. And maybe this leads to, people not being able to engage with what's being said on stage, or not really knowing why. But we kind of put this barrier between our sources on stage, or the content on stage, and our listener. So let's look at kind of a practical example, maybe something you can relate to, and then Nick will talk through kind of where we see how we solve some of these problems. So using our ears in an acoustic setting, we already kind of joked about, using our ear brain system is the best microphone system in the world. And I loved the example too about the comm system, because that really brings home this exact same point, which is, if you were to go to, let's say you go to hear a choir sing, right? And maybe it's your, maybe it's your wife's cousin's nephew's brother's former college roommate's kid or something. So you don't really care, but let's pretend that it's actually someone you know well, right? It's someone in your family's, or maybe a friend that you know, and you know their voice really well, or you could recognize their voice on the phone, in a crowd, whatever. So if you're listening to this choir sing, I'm sure you guys have probably experienced this. You're sitting there and you can actually pick out their vocal amongst a choir, simply because you're able to kind of localize to their voice and hear it not just tonally but spatially as well. And that is a really pleasant experience. You can kind of self-mix for yourself, where you can kind of pick out things, or things start to translate for you based on what you know. So let's say you took this same choir. They were really good, and they were going to do a recording, and they were going to put it on the internet to I don't know why they're doing it. they're putting it on the internet because it's going to be great. And so using a current like bus mixing approach here, let's say you put out all the stops, you got that mic drawer of your best microphones, right? You've begged, borrowed, and stolen from your friends in town, all the best mics you can get your hands on, or maybe even got some budget to rent some mics, right? So you went through this all, and you kind of set this up to record this choir. And then you played this recording back. You went through the really nice preamp stage. You went through the best recording software, the best AD conversion, all the best of the best. And you're listening to this recording on a $60,000 pair of headphones, right? You've got the best playback, closest to your ears as possible. And it still doesn't sound the same as if you were at that acoustic performance, where you were able to make a difference. You were able to hear the spatial information, that difference in time arrival from all of those different sources, our choir members, our sources on stage. All that was assembled together for you at your brain, and it's kind of a totally different experience than a traditional stereo listening experience. Why? Because we're getting that same kind of tonal, maybe we're getting the same type of frequency response, but we've stripped away all that spatial information, right? So let's say we did have the best recording setup ever. We spent $95,000. Nick and I turned this in. We wanted to do a real experiment on this, but we got put down. They said that was too much of a budget expense. So we didn't actually get to try this, but maybe you can try it at home, and we'd love to be a part of it. But you do all this and you're still having that same problem I discussed. You still kind of looking through a frosted glass because you're not getting the same information that you would be getting from those acoustic sources. So where does this leave us as far as where we currently are and how we see kind of moving into the future of sound that Nick's going to talk about? If you know anything about D&B Audiotechnik, we are traditionally known as a German loudspeaker manufacturer, and we obsess over loudspeaker systems, right? This is, one of our passions. We are always talking about cabinet design and system design and all that stuff, and this is obviously great. But we kind of see ourselves moving up the signal chain a little bit. So I'm not here to announce the new D&B microphone, so don't misquote me there. But as we move our way kind of up the signal chain and become more focused on what we're actually doing with the system, we also are kind of coming closer to the content creation side and not just reproducing the content, because now we're talking about systems that kind of give us that a new sense of control, a new level of what we can do with these systems. So we consider this kind of audio network, this stage right after the mixing console, this is really the bottleneck of all that spatial data. This is where we are losing that connection to the content that we would experience acoustically. So I think we'll talk a little bit more about that and kind of how we see crossing that bridge in an immersive fashion. I think Nick, did you want to see if we had any questions coming in, or really it's kind of been a lot of me talking for now. It'll be less just talking at you for the next little bit, but.
Yeah, as we mentioned earlier, I mean, talking and engagement is what we're really here for. And if anybody has any questions, now is a perfectly good time to ask them. Or we could get straight into what we're here to talk about today, which is the future of audio. And so far, not seeing any questions at the moment.
Yeah, I do see a couple questions. But I tell you what, I think that I think we're going to kind of get to them in a way that's kind of more self-evident, and we can circle back and see if and we'll present them a little bit further on.
Okay, great, fantastic. So I'm going to pick up right where Zach left off here. This idea of our bottleneck in the signal chain, and this is where we're losing all of that spatial information, never to be regained again. And so the idea from a D&B point of view here is modifying this bottleneck. And in D&B terms, we call this soundscape. Today's more about concepts than products. But the idea here from a D&B point of view is this processor has a situational awareness. It knows the location and orientation of all the loudspeakers in the venue. So it's already halfway bridged the gap between the content creation part of our signal chain and the content reproduction side. And the idea here is that all we have to do as a user is tell the processor where the source is located, which is why we call this object-based mixing. So a sound object can be placed anywhere within a user interface. This is a screenshot of R1, which is our proprietary control software for D&B amplifiers as well as processors. And this object just gets placed to represent where the source is located on stage, and the whole sound system then readapts to augment that location. Now, a sound object is happening in the processor, and how we utilize that is up to us as a user. It could be a single microphone, maybe on a post-fader direct out, or it could be a bus of microphones. Our processor handles 64 inputs, which means you are allowed up to 64 sound objects, depending on how you want to bus into the processor. And the idea here is that once you've told the processor where the object position is, where that acoustic source is located, because it already knows the layout and orientation of the loudspeakers, it's able to do an intelligent rendering in real time, where every loudspeaker gets a separate combination of level and delay for every sound object, which means we have a couple of pretty enormous benefits right off the bat. As shown here, no matter where you sit in the audience, you get stable localization, something that's a big advantage over stereo systems. So no matter where you sit, no matter what loudspeakers are covering you, you perceive positional data correctly to augment what's happening on stage. So right off the bat, we're reconnecting our eye brain system and our ear brain system. We're letting those world's best microphones and that processor between our ears get back to work. We're reconnecting this. So right off the bat, we see a lot of fidelity or intelligibility, as Zach said, improvements, because the user is able to self-mix again. They can then hone in on one part of this ensemble or this band and listen to that and reconnect. They can kind of filter out all of the data now that they have positional information back. Another key benefit here is that no two loudspeakers in the system are doing exactly the same job. They all have a different combination of time offsets and level offsets between these two hypothetical guitar players we see, which means that the headroom bottleneck has been mitigated. Every speaker is handling a different combination of things, so any poor interactions frequency-wise that happened in one speaker are not happening in any of the other speakers, and all of these interferences that we're used to in PA systems are now largely resolved. This also means that we're gaining headroom. So in most of these spatial system deployments, we're seeing that the size of the speaker can be downsized significantly. It's no longer a headroom game in the way that it used to be, because we have a coherent array of sources working as a team, all handling a different part of the job. And then back to Zach's idea about time alignment. When we place a sound object to represent its virtual position on stage, we're seeing delay processing to all of the available loudspeakers. So it's essentially recreating the same wavefront that we would have expected to hear in an acoustic environment, but now we're able to do it in an amplified environment as well. And this means that no matter where you sit in the audience, no matter what loudspeakers you're listening to, they are all time aligned to that object position separately. So this means no longer do we have multiple arrivals coming from the stage and from the PA. And even, in the old days, you could delay the PA back to something and maybe even get creative with input delay to pseudo time align each source individually, but it never worked for everyone the way that it does now. And because we have up to 64 sound objects, this can happen for a number of pieces of the ensemble at the same time. Again, allowing that user to demask, that head-related transfer function is now working again. And we're allowing the user, the audience member, to reconnect themselves the way that they're used to hearing in the natural world. This also means a complete paradigm shift in how we think about PA systems and setting them up. So we have some more case studies to look at later, but here's an example that I think will kind of drive home some basic concepts. This is for an installation up in Virginia. As you can tell, it's an Army base. This is a multi-use facility used for various types of ceremonies, performances, concerts, lectures, etc. And the room gets used often with very short notice. So they have to turn the room very quickly from one event type to another event type. And to illustrate that, we're going to look at this view, a plan view of the room, showing all the speaker positions. And sometimes this becomes the speaking facility for the President of the United States, which happens here. Other times they might have an orchestra concert here. They might have some drill events where they have spoken word content happening in separate places, different places. Or maybe it's the giant Christmas spectacular, which means they have an enormous choir, an enormous orchestra, a bunch of jazz bands, musical theater singers, you name it, it's all happening. And essentially the whole floor becomes a stage at this point. So we had a couple of limitations when we talked about this space. One of them was a quick turnaround time. That was a real constraint. And also they couldn't use line arrays because they were also installing a very large and wide video screen, and sightline impact was a major concern with a relatively low ceiling height. The problem with flipping a room very quickly is how do you realign the PA? How do you retune the PA? And sure, we could spend a whole week measuring and saving presets and give them a number of presets to go back to, and that's all fine and good. But then a new use case gets thrown at them, and maybe they aren't in a good position to adapt to that quickly. So, we did what we do with all D&B projects. We start an array calc, we predict it, we evaluate the coverage characteristics. And then in the case of a project like this, there's also a lot of lighting and other types of fixtures being installed. So we exported this data to CAD software so that it could be laid into the project master drawings to make sure there were no conflicts between lighting instruments and projectors and projection cones and speaker positions, etc. And I think this is an interesting case study because it allows us to illustrate the way we've been thinking about PA systems and the way that they can exist in the future. And so to kind of illustrate that, here's a basic concept here. This is what I think about when I'm lying in bed, dreaming about the future of live audio. So, for 20 years, I've been deploying PA systems, and typically my overall mentality goes something like this. I know, as the operator of this PA system, the designer of this PA system, I know where the loudspeakers are going to be located, or where they are located already. And I know this because I've predicted it in array calc or whatever manufacturer prediction software you use, or maybe you're using Ease or some other type of program. I know them in such detail, it's even been illustrated in CAD software, particularly for a very large corporate one-off or an installation. We have incredible detail about the position of these loudspeakers. And we really want to make sure that the installation or the deployment of this matches our plan on paper. So of course, we're measuring on site to make sure that the speakers get mounted in the right place. And it's interesting because what else do we know as a sound professional? Well, we know the speed of sound. This is not new information. In fact, I looked it up. We've known the speed of sound the human race has for about 380 years. So we have the positional loudspeakers, we know the speed of sound, and somehow, for some reason, it's still required of us to walk around the room with the measurement mic, making peak noise, looking at Smart or whatever favorite tuning software we have to time align all of this stuff. And it's kind of crazy when you think about it. It's kind of bizarre when you take a step back and look at this process and think, well, why are we having to do all of this? And the only reason is because in all of our PA deployments for the past 60 years or more, we've been missing one single piece of information. And that piece of information is where the source is located. We're essentially taking the long road around to fix a problem that is really just a very simple piece of missing information. So let's take this concept and apply it back to our example here at this Army base. They have 75 unique speaker positions. That means 75 delay times. And if this was not a soundscape system, we would have spent hours, days, maybe even a week walking around with a smart mic, making pink noise, entering delay times into amplifier channels, building them into presets so that they could all be recalled depending on what type of use case they have for the room that day. But because it is a soundscape installation, all they have to do is place the source. This now tells the processor where the source is located. It's that one piece of missing information. So it's handling all of the delay times automatically, not just to the first row, but also to the second row and the third row, happening in real time. We're no longer having to measure the acoustic responses PA to set delay times. It's happening in real time based on our object position. And as soon as they get another use case, they simply move the sound object somewhere else. the sound system is now completely realigned to that position. So not only have we restored the ability of the audience member to localize properly, reconnecting the ear-brain system and the eye-brain system, but we've greatly reduced the job to the operator and increased flexibility at the same time. And in this case, they couldn't use line arrays, so they had to do a distributed type of approach. And this really bridges the gap there for them. And in fact, of course, because we have 64 sound objects available, we could actually do both of these use cases at the same time if we wanted. So now that we have that concept out of the way, it's always people's next question: how many speakers do I need? What is the criteria for laying out the speakers? And I'm going to kind of give you a basic concept here. So we're going to take kind of a hypothetical speaker spacing. I like to work with real numbers, and I'm based in the US, so I'm going to transpose these to measurements of feet. And what we see here is this target listener, represented by the circle, is right on axis with the center loudspeaker. This is great. And what would happen in this typical setup is, because the neighboring loudspeakers are further away, we're going to see a level loss of approximately 3 dB from those neighboring loudspeakers to that closest target listener. That's 3 dB just because they're further away. But as we know as audio professionals, loudspeakers have some type of a dispersion specification or characteristic. So let's say this was a 90-degree box. So it has a dispersion of 90 degrees. That means its 6 dB down point is 45 degrees off in one direction and 45 degrees off in the other direction. This equals 90 degrees of total dispersion. Now, we're 3 dB down because of the increased distance to this neighboring loudspeaker, and we're also 6 dB down because of its dispersion characteristic, which means the level of that loudspeaker at this closest target listener is closer to 9 dB. Soundscape works totally different than typical traditional PA systems. This would be a very good approach for a typical PA system, because traditionally, with all loudspeakers receiving the same signal, you actually want to reduce the amount of coverage overlap between the loudspeakers, because this coverage overlap creates comb filtering and timing issues, which ultimately hurt intelligibility. Soundscape is a polar opposite. It actually depends on overlap between loudspeakers, because that's where all the trickery and black magic is happening inside the processor. So as an overall system design goal, we want the neighboring loudspeakers to be within 6 dB to that closest target listener. And there's a couple of basic blanket statements we could have here to kind of give you an idea of how this works. The first concept is, whenever possible, let's go with an enclosure design that has a wider dispersion characteristic. This allows for more overlap between the adjacent loudspeakers right off of the bat. And let's slightly reduce the amount of level loss by moving the outside speakers in towards the middle a little bit. We call this the 70% rule, or a 70% guideline here at D&B. The idea is, whatever the distance of the center loudspeaker to your target listener is, the adjacent loudspeaker should not exceed 70% of that distance. So we slide them in. And now we should be getting these loudspeakers within 6 dB to that closest target listener. So this does mean we want loudspeakers to be a little bit closer together than with our traditional PA. But let's also keep in mind that we have more sources supporting the workload, and no two loudspeakers are receiving exactly the same signal, which means that we can downsize these enclosures as well, which obviously has immense benefits when we talk about rigging, weights. It has immense benefits when we talk about sight lines. No longer are we having to do line arrays when sometimes we can get away with point sources, or instead of big point sources, we're using smaller point sources. To me, I think that's a pretty big value in its own, regardless of the sonic improvements that we expect. So then there's one more kind of concept I'm going to throw at you about this idea of object-based mixing, because this is always the next question. Well, what do I do with different parts of the system? What do I do if I have a mains set of speakers and a front fill set of speakers and some subs, how do I handle this? Because of course, they all need different data sent to them. Because in this case, the front fills, there's a higher quantity of them, which means their spacing is different than the main speakers, which means they need a whole separate algorithm of level and delay offset sent to them that the mains do. And this gets even more complicated if we really want to have fun with it and actually add surround speakers. Because of course, object-based mixing isn't necessarily about putting sound around the audience. That's just an added benefit. It's really about stabilizing the localization effects and allowing the listener to be able to demask themselves. So you start to see this idea of how complicated does it have to be to program this for the processor to be able to understand how to treat these loudspeakers separately. And of course, our deployment might include many more loudspeakers than this, especially if we have like a multi-level theater with balconies, which means we have under balcony fills. Now maybe we also have a second level of surround speakers for a balcony, or in this case, the second balcony highest doesn't have any surrounds at all. So those main speakers have to be processed separately than the ones for under balcony. How do we ensure that all of this works, no matter where we place a sound object, it renders in real time correctly in a way that matches our expectations as a human being? So the only thing we really have to do when we program a soundscape system is basically assign these speakers to teams. And each team will have a different mode of operation. There are 9 different modes available, and these are what we refer to as function groups. So all of our mains speakers in red would be in a function group with the mode mains. All of our front fills in yellow would be in a separate function group with the mode front fills, and the subs in a group with the mode subs, and you kind of get the idea. That way we can tell the processor what team a loudspeaker is playing on and a basic idea of what the expected behavior of that loudspeaker is. We want a front fill to behave differently than a mains. We want a 360 to behave different than a mains. We want an under balcony speaker to behave differently than the mains. And so simply by grouping these in array calc, the processor then knows speaker position, speaker orientation, and what team they're playing on, and automatically handles everything for us so that we can focus on just placing sound objects as needed. I think this is a good time for a break here for some questions.
Yeah, Nick, we had some really good questions coming in. And I think maybe, I know some of these we're going to address a little bit later, but this is good to get the idea going. One of the first questions was, does the 70% rule change based on the dispersion width of the loudspeaker?
Absolutely, it does. The wider the coverage characteristic of the loudspeaker is in the horizontal plane, the further apart the loudspeakers can be placed. We wanted this to really be concept-based and less product-based, but I can't not mention the new A series by D&B, which is available to go in a horizontal array of loudspeakers. And one of the prime applications for this speaker was to have a main speaker with the vertical footprint of a point source that could do 150 degrees of horizontal coverage broadband, which has immense benefits when we talk about soundscape and speakers placement.
Yeah, and I think it's interesting that as our listener position changes in relationship to our speaker, we need less and less density and resolution. So a front fill system might require more loudspeakers simply because our listener is so close to those sources, whereas a main system could be less positions because we can cover more people with those positions.
Mm-hmm. At the end of the day, we use array calc to evaluate the SPL and coverage of the loudspeaker with its trajectory towards the listening plane, and just make sure that they're overlapping within 6 dB of each other.
Yeah, another question was, so how does the imaging work even at the far side, like at the extreme ends of the venue with a soundscape system?
Yeah, I mean, the short answer is it depends on your object position. But there is a functionality for every sound object separately, which we call spread. And this allows you to control the horizontal dispersion of energy, wider or narrower, depending on your need. And just to further complicate things, we are able to change the spread per object to per function group as well. So by default, everything's in a middle ground, a middle setting. This is what we think will work for you for your applications. But if you find yourself in a position where you're not getting enough coverage all the way to the outside, you can widen up the spread either on that group of loudspeakers or for the object as a whole. And this works intelligently across different parts of our loudspeaker system. So this is one of the reasons why our mains are in a different function mode than our front fills. A front fills function mode anticipates a closer audience, which means if you go wide with the spread on a sound object, it automatically goes wider faster in the front fills than it does in the mains. I hope that makes sense.
Yeah, a few more questions along the same line. Basically, in a couple of these, I might kind of round into one. There was a question about how do you create a band mix, or how is this impacted by the operator or the mixer? Basically, these two ideas. And I think Nick showed it really well on a slide that was like, hey, we're thinking about these things as what we call sound objects. So a traditional bus-based system of, hey, I assign all of these inputs to my stereo mix and I pull those inputs up. This system doesn't work like that simply because it needs more information to achieve what it's trying to achieve. So we're not just taking a stereo signal and spreading it out. Each one of these inputs has to be somewhat discrete in a way that we're, these sound objects, whether it be a combination of microphones or a single microphone or a playback track or whatever, we're basically feeding this direct out into the PA system. So we're, if we fed a direct out into the processor, we're still using our fader. We've still got the ability to do EQ and compression and send that signal wherever we want. But no longer are we saying, hey, everybody jump on the same mix bus and go out to the mains. Everyone has their own path to the PA system as far as an input goes. So when you're talking about building a mix, in some ways, this becomes a little bit easier because it's kind of simple to be like, I want to put this object here and this object here and this object here. And we talk a lot about this, about how it relates to the visual. And obviously that doesn't always translate to what's happening on stage. Maybe we don't want it for artistic effect. We want it to be different than what's happening on stage. We want it to be bigger or smaller or whatever. So how we're controlling these objects, I think Nick's going to jump into in a second. But one of the other questions too was, is there any thought to, when we are thinking about it visually, tracking these objects with, say, a presenter or a guitar player or something? Is there any thought in that?
Yeah, great segue. Thanks, Zach. So the DS100 can receive OSC commands. This stands for Open Sound Controller, and it's essentially just a type of Ethernet communication from manufacturer A to manufacturer B. And this really opens the door on how Soundscape can be controlled. So the screenshot I showed earlier showed it controlled from its native software, which is R1. You can just move the sound object with a mouse, or maybe you even have a touch screen on your computer. But this also means that we can now receive positional control from one of your favorite consoles. So you can actually put the positional information on a per track control within your console, and then save it as a snapshot. So when the snapshot gets recalled, all of your object positions go back to their desired location. This also means that we can use a whole variety of mobile applications like Touch OSC. So we can walk around the venue and control object position, either for an individual object, or we can even grab a group of objects. It supports multi-touch and move a bunch of positions all at once. Skipping ahead just a little bit. We also support tracking systems. So, in this case with black tracks, the presenter or artist on stage will wear a beacon, which tracks their position. All of this information can be relayed from the black track server directly to the DS100. So you see all the objects move automatically. And if this is already in use on a show for lighting or video automation, we can just grab that existing stream and pipe it right into the DS100. We also make plugins that run in your favorite DAW software. The plugin doesn't actually process audio, but it allows you to record automation tracks, and then the plugin will relay this information to the DS100. So what we see here is my mouse is moving the object position around the screen, and we can see it recording that movement in automation tracks of the DAW. And this means that as I play back audio off of this digital audio workstation, it will automatically record that or play back that automation information and relay that to the DS100. So these plugins work in VST, AU, and AAX formats, so run on whatever your favorite DAW program is. Or we also have native support within QLab. So if you are using QLab on a show already, you can program a network queue, drop an image file of your venue in there if you want some good visual acuity. And then what happens is as you fire a cue, you're actually able to track a trajectory of a sound object. So this could be a pre-recorded movement of the object, which is really handy to have in QLab, particularly if you're already using QLab for the audio playback and video playback, console snapshots, whatever other type of show automation you use. So this is natively supported in QLab as well. We really tried to meet the market halfway with all of these different control protocols so it can, integrate into your existing workflow.
Yeah, I mean, console plugins, software plugins, there's all that stuff. And some of that information is available in the link and the handouts we sent. We tried to keep this presentation as, we want to talk about the product, obviously, some of the products, obviously, but, more conceptual in nature. A couple more questions, Nick, we can jump through and then you can keep going. So there were a few questions about, does every, sorry, I just want to make sure I don't misquote someone. So basically the question is, so objects that have different spatial locations would need to be fed to the matrix separately in order to be calculated spatially individually. And I think that's one thing, since we weren't trying to talk about the product, we didn't just jump in with a, here's the product, here's what it does. But the DS100 by itself is a 64 by 64 Dante matrix. So Dante is what's driving it in and out. We're using that control protocol Nick talked about to do the movement, to do playback, all that stuff. But at its base, it's a 64 by 64 cross point matrix. So the same way we would use a matrix as far as getting signal in and out of it, kind of those kind of that same logic still applies. But now we're giving the processor more information. It knows our loudspeaker positions, which kind of, there was another question that said, basically, sorry, once again, I don't want to misquote somebody. Basically, what's happening in the processor as far as, sorry, I totally lost it. I guess the basic idea is behind a couple of these questions was, from a user interface perspective, how much control do we have as far as when we're deploying these systems? Do we get to specify any kind of delay times? Do we get to, other than just placing an object, what are we telling the system? What's required of us to make this work?
I mean, there's still a large suite of processing available on every input and every output of the processor. So you could apply equalization and delay or whatever you want there. But for the most part, it's handling all of that distribution automatically. We can also support manual routing, and this can happen at the same time as object-based mixing. So every input to the processor can either be an object or a matrix input. And if it's a matrix input, it can be manually routed to any output. But as soon as we switch it to an object input, that becomes automated in varying degrees depending on your mode and the details of your operation. And what we really find generally is that less processing is required when we use spatial audio. Now that we're reconnecting the ear-brain system and the eye-brain system, that the thing that Zach talked about, the job of the mix engineer of demasking things because it's all coming down one bus and coming out of one loudspeaker, a large portion of that job goes away. So I like to think of it as we're replacing the channel strip job, which is this kind of black magic of sound engineering. What makes a good sound engineer, what makes a bad sound engineer, who knows, because we all do it different. It's eliminating part of that and just letting you work on a graphical interface and let the system do it for you and let the listeners be able to work. So I find I prepare a lot of content for Soundscape demos. I usually start by mixing it in headphones or my fancy near field monitors at home. on stereo, and then when I get on the speaker system, I pipe it in Soundscape. And the first thing I do is decide that my mix sounds like garbage. Now it's in Soundscape, and I bypass all of my channel processing, and then the mix sounds great. I can't tell you how many times I've had this experience.
Okay,
Does that answer the question?
I think so, in a way. Let's do a couple more here, and then we'll jump back in. And then, because I know there's a couple in the list that we've gotten that you're going to kind of hit on, so I don't want to think we're shortchanging anybody, but we're going to get to those ideas. One of the questions was about black tracks and what frequency is, how is it working? Is it using a certain wireless frequency or a band or whatever? And I think it's really interesting. The black tracks, this works with several different tracking protocols, so you're not just stuck to a specific one. And but the folks at Black Tracks have always been really great for us. They always help us out. Every year we do, whether it be Infocom or NAM or one of these shows, we always do a demonstration, and we have Black Tracks as part of that. And the way that their system works, and I don't work for them, so if I get something wrong, I apologize. But basically, you've got an array of cameras that's spaced throughout the room, and these beacons are basically triangulating positions based off what those cameras are seeing. So they're not to get super far into it, but it's more about what the sensors are doing than less about what's happening RF wise. It's more about tracking based on what the camera is seeing in the camera, and their server is translating that data to our processor to say, hey, you basically just tell them this is the coordinate system we're using. And one of the things that Nick kind of mentioned, all this information we've given the processor, keep in mind our entire system deployment and our entire space we're working in is all based off our array calc model. So the way the DMB workflow kind of works is we build our model of our room not only for our prediction, but where our speaker positions are located. This in turn gives us a canvas to work on. And not only is this a quick way to build a canvas for a project, but it also gives us scalability. So as we go through different types of deployments, we can adapt the venue to what we're doing that day.
Mm-hmm.
That question was for me. So BlackTrack doesn't use any RF, right?
No, it's actually based on infrared. The beacon is a infrared transmitter that has a certain blink rate or refresh rate that is timed to make it unique compared to other emitters, and the cameras can decipher one emitter versus another. I think they support 128 beacons, something like that.
Yeah, and a lot of folks are using it for video, lighting, all the circ shows, all those things where they're doing a lot of intricate tracking. They're already using these type systems, so we thought that would be a great approach.
But you don't know what frequency band they use, right?
It is infrared. It is light-based camera grab, and I do believe there is also a Wi-Fi network, a 2.4 gig Wi-Fi network that handles some telemetry communication with the bell pack, I think.
Yeah, we can send out add that to the link, some information about Black Tracks if that's something people are interested in for sure.
They're very friendly Canadians to the north.
There, two more questions, Nick. Sorry, I've said that like 3 times. Basically, one which I thought was really interesting, which was how does stage volume kind of play into this? How does this affect, all of a sudden we're kind of a little more concerned about, hey, we do the best to get the spatialization right. How does stage volume play into that?
Well, finally, our amplification system is properly timed to the acoustic source for everything. So it's much less about having to overcome stage volume than it was in the past. I see anecdotally a lot of people mixing shows inherently quieter because I think it's a tendency for sound engineers, even the best of us, to push a fader up to try to regain clarity. And as soon as you're not fighting stage volume but working with it, you have less of a tendency to do that. I mean, particularly when we talk about, classical, opera, traditional jazz, the shows that don't want to sound amplified, musical theater, great example. You want the PA to sonically disappear so that you're focused on what's happening on stage. And that's really what's happening with the soundscape system in general. And you're having to work less for it. Just going back to the basic physics of the PA and letting it do the work for you.
Yeah, there's a couple more here, but I think let's keep moving through the presentation. And there's going to be a nice part where we can address some of these.
Mm-hmm. Fantastic. Good questions, everybody. I love this stuff. Where are we at? Oh, yeah, right back here. So far, are you seeing my screen? No?
We're still seeing the wallpaper.
There we go. Beautiful. Great. So then I press this button. Whew, too many computers. Great. Oh, you're still seeing the wallpaper.
Yep, which we did have a question. Someone wants to know where they can get the wallpaper. Okay,
Yeah,
we were
I should
back.
probably
We were
put
back.
it in that folder.
Yeah, we see the scribble now.
Yeah, you see the scribble.
We had
You
your
see
presentation for about 2 seconds.
that. Yeah. This is what happens when we multitask.
There you go.
There we
You're
go.
All right.
So far what we've talked about is this object-based mixing, the idea of localization, which really applies to forward-facing PA systems as well as 360-degree speaker deployments. Emulated room acoustics is this whole other part of it, which I think is really interesting, particularly with 360-degree speaker deployments, overhead speakers, et cetera. And the way that we're handling this kind of allows for what I like to call a reverb on an aux style mixing, but with actual room emulation, not just your typical stereo reverb. And what happens is our clever Germans back at HQ came out with these custom designed little omnidirectional speaker systems with a special amp firmware they load into our D80 amplifiers. And this is a way for them to activate room acoustics in a hall. And the idea here is that they want to grab what they call an impulse response, which for anybody who isn't familiar, this is the measurement of sound behavior over time. So in this hypothetical impulse response here, we could see an initial arrival from the acoustic source, and then it trailing off as the room adds reflections and reverberation. So the idea here with what we call MSpace, that's a product for emulated room acoustics that runs within the Soundscape processor. The idea here is that our Germans have traveled the world, going to some of the most optimum acoustic spaces they can find and using these speakers to activate the room acoustics and taking a very large number of impulse response measurements. So here's a plan view of that same room. They place 4 speakers in this room to represent sound arrival from 4 different source positions in the acoustic space, right? The way that sound travels to one side of the room versus the other side of the room differs on whether the sound originated from stage left or stage right or out in the audience. So they have 4 of these speakers, these room activators, and then they're taking a very large number of impulse response measurements at the boundary of these concert halls. Each one of these measurements is measured 4 times, once from each one of the 4 speaker positions, so it gets the kind of impulse response data to represent different parts of the room. And each one of these measurements is what I like to call geotagged. We make a note of where in the venue all of these measurements took place. In reality, it's not just what we see here, but it's closer to 200 or 300 impulse response measurements from a room. And all of these impulse responses get geotagged and loaded within the DS100. So we now have a 3-dimensional model, acoustic model of this, whatever example concert hall built into the venue library of the processor, which means when we deploy a loudspeaker system, in this case, it's a square 360-degree type of concept, all of these impulse responses are automatically applied to our speaker deployment to represent their initial measurement position. So we are recreating this space in 3 dimensions in real time, and we are taking into account different source positions. So I like to think of this as a 4-input, 144 output reverb machine. The 144 outputs are happening virtually within the processor, and then down mixed to a maximum of 64 outputs for our speaker system. But this allows us to really replicate the acoustic fingerprint of this hall in real time for our content coming from the stage. So our controls here are basically a drop-down list of all of the halls that are included within the library, and then a couple of basic faders to tailor them to our needs acoustically. The first fader is pre-delay factor. So when it's at 1, right in the middle, its default position, all of the pre-delays occurring from this emulated room acoustics match the pre-delays of the room that was measured. We're emulating this room exactly. But we can scale this up or down to increase or decrease the acoustic volume of the space virtually for it to match our artistic needs. Then we are also able to control the rear level, which is this kind of smart way of cross-fading front and back overall level in order to kind of control the immersiveness or the surroundingness of this effect. Again, for our acoustic needs. So some examples of the halls within the acoustic library. We have a lot of classical music halls, including some of the world's most famous Viennese concert halls and whatnot. These are great for traditional types of music, but they also translate well as what I like to call the world's best drum reverb, or your kind of house of worship vocal effects. It works very well. We also have a couple of halls recently added for more of an effect, less of a room emulation. To give you an idea, this shows the reverb times per frequency of a bunch of the halls in the venue library. So depending on if it's more classical operatic or traditional jazz or theater or a Gregorian chant, I don't know, you might want the cathedral for that, but you can pick a room whose acoustic response really matches what you're trying to do and then scale it based on its settings for your artistic needs. It's a pretty short presentation because from an operator's point of view, it's pretty simple, even though running 144 impulse response convolutions in the processor is a different story. But we wanted this system to be easily deployable, quickly, and within a sound guy set of kind of terms and usability. So that this code, for example, this could be deployed on a one-off show that loads in the morning and sound checks in the afternoon easily as a turnkey solution. Yeah, so I mean, any questions about this now that we've introduced this kind of additional layer of what's going on in Soundscape or what its capabilities are?
I think there's a couple more questions in general. And I apologize to everyone because I had the sheet up of the questions and I had the column of people's names. I didn't even see the names, so I apologize. That these people do have names and hearts and families. I'm so sorry. But a couple more questions, and one that was a good point here was basically, so it's a couple along the same lines of how do we speaker, this is a question from Stan. It says speaker location accuracy seems to be critical. Can a CAD or something like that be imported?
I mean, we do make a plugin for SketchUp that allows you to import your favorite architectural drawing format of choice, select objects within that drawing and export that directly into a RayCalc. It only supports the venue elements, but there are some creative ways to get speaker positions out of that. But you are correct that speaker position is important. I like to say when we commission a Soundscape system, instead of bringing the smart mic, we're bringing a laser disto to confirm that the as-built matches the file.
Yeah, because it's even if something was deployed differently, it's no. I mean, obviously we wish it was deployed like we said, but now it becomes an issue of let's make sure we change our file so the processor knows, hey, this speaker is 3 feet different than what you originally planned because, oh, guess what? There was a giant plant right there or whatever you thought was going to be there.
No, I mean, every installation starts with optimum speaker positions until the contractor gets on site and realizes there's no studs there, or there's a water pipe in the wall, or an exit sign that can't be blocked or something. So yeah, we just adapt the file to match the as-built speaker positions.
Yeah, here's a question, kind of along the same. A couple questions along the same lines. A question from John. He says, mix structures that make use of stereo effects processors and subgroups. How do mix engineers change their approach on an object-based system? Fold these to mono objects, group stereo objects. How does our approach change?
Yeah, we get this question a lot. I mean, especially when we talk about like compression mixing and these types of kind of classic techniques. You do have to keep this in mind as you're building a mix and you're building your approach. I mean, in the case of, let's say we're using parallel compression on a drum subgroup, That could be a stereo subgroup, and that stereo subgroup could feed two sound objects, one that represents the left side of the signal and one that represents the right side of the signal. And you could either place them very close together to match the acoustic source of that drum set, or you could get kind of wacky and have some fun and place them out extra wide, or you could vary it depending on parts of the show. Or if I was mixing, my approach after working on a lot of soundscape systems now would be to do something like a single bus that has all of my anchor drum channels, like kick, snare, hat, and then maybe a stereo bus that has, the overheads and the toms and the reverb returns and whatever else is going on, to be able to make those as wide as I want without moving my anchor inputs. So I might bus it differently for that application, absolutely.
Yeah, it's one of the systems I worked on. For a house of worship, it was basically like, hey, we might 5 minutes before get thrown a guest guy that's going to come plug a guitar in, or a video that we didn't have time to mix, or so we basically ended up making two objects. One was kind of the left and the right, fed by the stereo bus. And hey, if you have to pull up something, throw it in the stereo and it goes to this left-right system, and it's still better than just a traditional stereo system because it's got, the time alignment is done for you between all the sources. So you still got the benefits of that. It's not the same spatial experience, but don't be scared of the fact that you have to have an object for everything as a barrier, because you can kind of give yourself some setup for that kind of last minute emergency stuff that maybe you don't have a time to pre-plan.
Yeah, I mean, we see multi-use facilities where maybe the local AV guys show up with their Mackie mixer to do the little spoken word event, and we can provide them just a mono XLR input that's associated with a single object on the screen, and they can just move that one object to represent their stage position, and whatever available loudspeakers will realign to that orientation of the venue. This is really great in lobbies with ceiling speakers, multifunction use spaces, very utilitarian, but it allows them to flip the room very quickly without having to think about delay times. There was another question here about the Army base. Mentioned there were 75 speakers. Does that mean it's scalable with 2 or more processors? The answer is it is not yet scalable. So we are restricted to 64 DSP outputs. And in the case of that speaker deployment that had more than 64, we were actually putting speakers in the same position and running them off of one DSP output, so that the 2 speakers, even though they were wider in coverage because it was a small array of point sources, was receiving a single delay time from the processor. Good question, though. You almost caught me. Tried to bust me.
Yeah, you mind if we do a couple more?
Yeah, let's do it. I love it.
Yeah.
Here's one I like. The guys at Black Tracks owe us. Coming for you, Dakar. Will Black Track support multiple devices on a person to help relay a person's body orientation? Yes, absolutely. Each belt pack can support up to 3 infrared emitters. These emitters could be placed maybe left and right shoulder, or 2 on the back, 1 on the front, and it can relay actual orientation. So yes, it is possible. Soundscape processor is not using orientation information, just positional information, but their tracking system is capable of that.
Yeah, that question was from Kenneth. See, I remember people's names. You are not. Along that same line, Sebastian mentioned, there are also obviously several of these tracking kind of time tax stage trackers, Zach Tracks, which somehow never sent me a shirt, even though it's my name. Yeah, so there's definitely options here, and as long as they can kind of output the appropriate data, it's kind of game on as far as what you could do with the processor. Here's another question, Nick, that I think is interesting from Stan. It says, in very large spaces, convention halls, as you move back into the room, stage location seems to lose a bit of relevance. How does the system benefit in that circumstance as the listener is hundreds of feet away, possibly?
Yeah, that's a great question. Yeah, as you get further back, your perspective narrows, not just visually, but also orally. And so, yeah, I mean, as a concept, the further away you get from the acoustic source, the more it becomes a mono down mix, which is handled automatically. There are also modes of the DS100 where you can have mono outfill outputs that still have time alignment to the source, but every object is mixed to that speaker position equally. This might come in handy if you have just a single speaker filling a remote location and you don't need the spatial information, but the time alignment is still important, so we can support that. Yes, though, generally speaking, if we talk about maybe if 4 sources were required for the mains to cover the floor of a theater, by the time you get up to the top level balcony, maybe we only needed 2 speakers or 3 or something. Because they're further away, they have diminishing resolution, and those speakers are further away from the audience members. So yes. And these types of questions, if you want to look at a design for your venue or your event, this is what the support team is here for. So feel free to email support@dbaudio.com. And we have a whole team of people who, you know, if you want to sit down and look over Zoom or whatever video chat software and look at a design together and talk about it, we're happy to do that.
Yeah, so as you kind of got to into in space, there was some questions about let's see, I'm trying to think. Kenneth asked, can the reverb space or the in space be changed via QLab? In other words, scene 1 is in a church, scene 2 is a small room like a kitchen, scene 3 is an amphitheater. Can you do that via QLab control, change the space?
Absolutely. Yeah, you can change it in real time, and you can change which sound objects send to the emulated room acoustics and at what ratio. So you can have parts of your show affected by the emulated room acoustics and other parts not affected, and change all the parameters of the engine in real time. We don't yet have a kitchen or like a subway or those kinds of cool spaces for those theatrical effects. A lot of people are modifying the existing spaces to approximate that type of acoustic behavior, but I would like to see more of that. Yeah.
You know, maybe while you're working at home, we could get your hands on one of those speakers and model your kitchen. That would be, I would support that.
I don't know if my wife would support 3 days of high SPL signs. I like the concept.
Maybe just get her a dog or something, keep her entertained for 3 days and say, look, the dog's just not working out. You know what? I think.
Yeah, fair enough. I'm not sure the dog will like the high SPL sign sweeps once we get up to 10K.
Just keep it at a low frequency, you know, nothing above 10K. Okay. A couple more things I know, Nick, we wanted to jump into, but let's look at along that same lines of kind of how you control things. There's a question from James. It says, with dynamic panning, are delay times changed in real life? And if so, how do you avoid a Doppler shift?
Yeah, great question. By default, when you move an object position, it's changing delays to every loudspeaker separately. We don't typically see a problem with Doppler, which is, you know, the audible effect of a pitch shift because of very fast moving sounds, typically because the object itself isn't really moving and it's stepping a delay time. It's also typically not moving all that fast. But what we see commonly are the potential for delay stepping artifacts. If you move an object very quick, the processor is very good at updating quickly, but it's not like an analog piece of gear. It does actually shift delay time digitally. And in which case there are separate modes that we can put the sound object in. Full mode is with full time alignment to the acoustic source and all the delay processing. Then there's a tight mode, which is kind of like a latency compensation in a DAW. It reduces the overall latency, but still keeps delay times between loudspeakers. And then the third mode we call off. And this basically sets that one sound object to level-based panning only. So this is very good if you want a sound to whip around the room very, very quickly, and it's an effect, so you don't really need the delay as much. You can do that without, you know, inheriting any side effects of delay stepping. But for the vast majority of applications, you got to get an object moving pretty quickly before you start hearing that. But there are options for your show. Here's a question. Do you see the system being used to apply in a theme park style environment to something like an expo hall of a convention center? Part 2, can we isolate parts of the expo hall from each other? So part 1, yes. There are a lot of interesting applications for this processor. Talking to some of our friends down in Brazil, they wanted to potentially use this for Carnival, where they have floats traveling down the street, but local PA system towers down the parade route to augment audio content that's coming from the float. And in the past, they basically had a whole group of guys turning knobs, trying to follow the floats down the road. And now we could just move an object to do it. I think that's one example of a theme park type application. Part two of that, can we split the behavior of two rooms? And the answer is not with the emulated room acoustics or object-based mixing. The processor works as one room per se, but it does operate as a matrix mixer, which you could use it to distribute audio across a theme park or multi-rooms of a convention center, or multiple locations of a multi-property church. It's audio over IP, so you can send this over extremely long distances and route as needed, just like you were using a SoundWeb or an LM44 or a Galileo Callisto or whatever your favorite processor is. It can do that type of functionality as well.
Yeah, we've seen some really creative uses already too. With one of our customers that does a large sports arena, they have a second soundscape system just for basically a rehearsal space. So they've basically recreated the arena in their small little room, and they create their content for events, kind of like the same way they would. So they know their stuff's going to translate. So some weird stuff that we kind of even never really thought about, we're already seeing people do there.
Mm-hmm. Here's another question. Can playback do similar stereo image everywhere, no object location? And I think what this is referring to, correct me if I'm wrong.
That was from Pete, so
yeah.
Pete can correct you.
What I envision with this question is what I call soundscape stereo. It's where we take a stereo mix and we apply it to two sound objects and position one of them left and position the other one right. So in which case we're using an array of more sources, and the objects are upmixing the stereo content to this array. So yes, this is a way to take existing stereo content and upmix it to make the sweet spot larger. Oh, sorry, Pete, I think you're muted.
He's being censored by the FCC right now.
They definitely didn't want me to say what I'm about to say. What I actually was thinking about is a multi-track playback where each track is an object, where you imagine where they are. So this group of sounds would sound the same spatial width to everybody, no matter where they are, front of them, back of them, side of the room, everywhere.
Yeah, I mean, we talk about 5.1 content for a live environment. It's a bit of a nightmare because whoever sits in the back row is getting
never right
with the surround channel.
Right.
Yeah. So if we take 5.1 at 6 signals, 5 high mid speakers and a LFE or a sub, and we apply these to 6 sound objects, we place them virtually to replicate our studio it was mixed in, and it upmixes it to the available loudspeakers, mitigating much of that sweet spot, because the left-right sweet spot is bad enough. As soon as we introduce 5.1, we now have a front-to-back sweet spot on top of it. So it's really on an island in the middle that's getting that proper localization. Surround content. Yeah.
I was on a show once where the producer arranged for the main client to have a particular seat because that's where all the effects sounded best.
Yeah. In a previous lifetime, I used to mix some of Meyer Sound's internal events, and my first question was always, "Where's John Meyer sitting?" Because I'm going to tune the whole PA for that. Yeah, absolutely, I understand.
Exactly.
Yeah.
Nick, great. let's maybe jump back into the presentation for a second, and then we can come back here. Still some great questions to go, but I think there's a couple more things I want to make sure we get in there.
Yeah, a couple of good case studies to get people's wheels turning here. I think this could be really cool. The first one Zach's going to take, but it's harping on this concept of reduced sightline impact because we can use smaller sources.
Yeah, so
sorry, go ahead.
Let's don't out-polite each other here. So, if we're looking at maybe a traditional, let's think of maybe like a house of worship or something that's kind of fan-shaped, maybe a convention hall that's like that, and we might have to do, a lot of times people kind of think about these systems, think, well, yeah, that's really cool, but I have to use a lot of speakers and I need a lot of channels, and I just that's never going to be in my budget, right? And that's partially, I think, a fault of the audio industry in general, or of the manufacturers that have come out with these types of systems, because you go to a demo room and it's whiz bang, well, oh wow, cool, look, I'm in a jungle, I just jumped off of an airplane, or it's like, okay, that was really cool, I could never do that, I don't have 32 speaker positions, right? So we kind of made this like this unapproachable thing, but at its base, at what Nick mentioned of kind of trying to restore that all that timing information and kind of taking the mask off there. But so if we think about that idea and think, okay, let's look at how we would traditionally do this, right? If we used, let's say, a medium-sized line array here, in this case, we have 32 boxes, 4 hangs, to kind of give us the appropriate horizontal. The 4 hangs are giving us the appropriate horizontal dispersion. The vertical dispersion that's really what's determining how many cabinets we put in an array, how much coverage do we need vertically. So let's say in this setup we've got 16 amp channels, right? If we took this setup and looked at maybe a soundscape version of this, maybe it was 8 point sources or 7, depending on how wide the room was or something. It's 8 point sources, 8 individual boxes, and only 8 amp channels in this case, right? Because if we have a at D&B, as far as loudspeaker design goes, we kind of obsess over pattern control. So we're always looking at isobars of cabinets and how a box holds its pattern. So if we have a box that we know its dispersion, and we can take advantage of the way it's designed for vertical directivity and vertical dispersion and get the appropriate level, we probably could do this with more sources spaced out. And think about the fact that we don't need as much headroom out of the PA, because we're not asking every source in the system to reproduce everything. We're letting them kind of work as a team and kind of taking the stress off those from a headroom perspective. So this is one example I like to show. In a real world example, this is a church here in the States that basically, large fan-shaped room like you might expect. And one of the questions we had about, how does this work when you're very wide or you're very far towards the end? That's kind of the problem. A couple problems they identified. One was this giant video screen. No one here has ever had to give up any room for video, right? We've never had to bow to video's demands, right? That's never happened.
Never.
They had yes, thank you. So, they had that kind of, hey, sight lines. We can't have a PA down in front of, we can't have these big giant line arrays in front of our video screen because we just bought this big video screen. So, that was important. Another thing was this church, and we see this all the time with people like the, organizations like this. Maybe they've kind of they've saved up and they've finally kind of moved into a nice big building and they're really excited, but they can actually see an attendance drop off when they move up to a new building, because it's kind of alienating to be like, okay, I'm not used to this. This place is too big. I'm not really connected with what's going on. And a system like this that could restore that connection, both visually with what they saw and kind of what they hear. And so that was kind of something that sold them on it. So that kind of sounds salesy and markety, and I know we're all tech guys, but just back to the concept of that connection from stage. So Nick, I think you've got the next slide is a picture that shows what the deployment.
Well, and real quick, there was a third thing that resonates with the tech guys. I look at this picture on the right and I see 16 quote lead vocalists in front of a large choir. This is a handful to mix.
Yeah, that's what I was going to say.
Don't have any spatial information. Sorry, I didn't mean to steal your thunder there.
No, but totally. That's what, and everybody's mic is, yeah. Sorry, let's don't get in disparaging about the level of how talented the input was coming in. Who knows? But so in this case, you can see kind of the picture on the right of the deployment. So we were able to do kind of some smaller arrays. We still had to get a certain amount of vertical coverage, but we didn't need necessarily as big of a system to get that headroom out. So we did more positions of smaller cabinets, and they're using Soundscape to kind of achieve this and change, the width of these objects, kind of like Nick talked about a bit, and where these things are placed. So all of a sudden, and it's crazy, even, if you got, usually we do these type of demonstrations, we have a system with us to walk through and people can play with. So you can't discount that experience. We can tell you all about it here. And, we've got a facility in Asheville, North Carolina, and in Signal Hill, California, right outside of LA, that both have systems like this. So when things get back to normal, we'd love to have you guys there. But, it's just the ability to move things even as simply as upstage and downstage, like that choir and the vocal, to give you some room in the mix. Things that you maybe could have done if you spent all the time adding delay to all these channels and matrixing and all this stuff, but that to a church who has probably a not very experienced engineer in their case, or volunteers, they can't all go get their CTS credits on the weekend. But what you can show them? How to move an object where you see it on stage. And that translates, kind of takes away the scariness of an object-based system to think, hey, you know what? This may be a little bit more work to design, but once I'm operating it, man, I'm making my life easier and I can focus on more, important choices I need to make with the system. This next example is kind of in the round, and there was some talk about that and some of the questions about, what could you do? And maybe if we had a traditional, maybe this is a corporate type event where, everybody wants to do in the round because it's so engaging, and we always go, great, but they want to do in the round or theatrical in the round. And traditionally, we might have a system like this with speakers in the middle that kind of cover, they're radiating outwards to reinforce what's happening on stage. And then maybe we have some surround speakers, right? But the inherent issue with these systems is they don't usually work well together, simply because you kind of can't use them in a way that augments the other. So if you move it around an object to the right side of the stage, it'd be nice to take advantage of those speakers on that side of the stage as well, not just have them as a separate surround and a main system. So using sound objects, being able to set what kind of mode they are and how they move around, we're seeing in the round deployments like this being made a lot easier to deploy. You don't have to sit out there with your calculator figuring out delay times to make it work right. It's just kind of plug and play, and that's kind of always been our approach of like, hey, this should be something that you don't have to pay someone to come in and commission every time you want to do. You should be able to build this yourself. If you know how to use an audio system, you should be able to do this. And even we had a client that did a large corporate event with 360 video, and they would have different types of presentations to kind of break up the content, and just to be able to be like, okay, this object is that playback channel, this object is that playback channel. No more going through a matrix and doing all that, just moving an object. So this is a case study we've seen a few times already, and been really surprised with how well it works.
Yeah, I love the idea of this object flying around the room in a circle. And not only does it come out of the outer speakers, but the inner speakers intelligently work as a delay, augmenting that position as needed as the object moves. This is something that's just never really been possible before. Now, looking more at the emulated room acoustics, we did an event here with the San Francisco Symphony. This is a picture of their beautiful Davies Concert Hall in downtown San Francisco. The acoustic renovation of this hall cost $130 million. That was just the acoustic renovation. But like most symphony orchestras, they have an outreach program where they're doing outdoor concerts at the park. And if anybody's ever worked an outdoor classical concert, it's challenging. The musicians are never happy. The audience is never happy. And that's because there is that last member of the orchestra missing. That last member is the concert hall. The music is written to take place in a concert hall, and we can use the most expensive reverbs known to man. And as long as they're coming out of a stereo PA, it's just never going to approximate the hall. So even though we weren't using object-based mixing on this event, what we did do is place 12 point source speakers around this 8,000 person audience. So 4 speakers per side, 4 speakers on the rear. And we're able to pipe and space the emulated room acoustics out of these surround speakers, as well as the mains and the front fills. So it's a very simple system routing wise. The whole system was fed by a stereo mix coming out of the front of house board. And then we used the DS100 to apply this multi-channel reverberation, this emulated room acoustics in real time. We also had the benefit of using the GSL loudspeaker system, which has broadband directivity. So it's kind of nice that you don't have to worry about feedback out of a bunch of overhead chef's mics anymore, because that used to be the name of the game for this front of house engineer, was basically just trying to keep the PA from feeding back. So kind of the best of both worlds here for this event. And then another example I like to show when we talk about the emulated room acoustics is here at Stanford University, we actually installed 2 DS100s into one venue. One DS100 is operated by a sound engineer. This runs object-based mixing and emulated room acoustics for the audience area. Whether it's fed from console inputs or fed from overhead microphones, the choice is up to the sound operator. And so that's kind of what we would consider a typical soundscape installation. But where it really gets interesting, I think, is a second DS100 just runs a virtual orchestra shell over the stage. So this way, when the symphony orchestra has to come in here to practice, they don't normally, they don't get to go to their $150 million concert hall because it has another concert booked. So they have to come back into this much smaller space. And of course, rehearsing in this type of acoustic environment is very off-putting for them, especially since they'll be doing the performance in a much larger concert hall. So this system is powered exclusively by suspended microphones we see in green, or visualize more like this. These microphones feed directly into some preamps, which convert the signal to Dante, that feeds directly to the processor, which feeds to the outputs of the processors. And then that way, this can be operated by this touch screen on the side of the stage by non-technical users. They don't have to plug anything in. They don't have to, muck around with mic stands. They just walk to the side of the stage, they turn the system on, and they pick which type of acoustic space they'd like to emulate, and then that happens in real time for their rehearsals of the acoustic ensemble on stage. So even though the concepts are pretty simple on how this works, the way we deploy it really allows a lot of room for creativity, which is really fun to see now that we're really getting out in the market with this stuff. So that's the end of the formal presentation stuff. We're in a full-on Q&A time now.
Yeah, along that line, Nick, about the virtual orchestra shell and the kind of the acoustics of the room. 2 questions I think that would be interesting here. Question from Marissa that said, how limiting are the natural acoustics of the space in the room emulation?
Mm-hmm. Yeah, I mean, our room emulation is an inline technology. This has some benefits in that you have less gain before feedback issues, as with some other types of systems that work on a regenerative technology. But like all of these systems, it is still an additive technology. So meaning that it will not compensate for any acoustics already happening in the room. And with all things being equal, we would say we would want a more acoustically dead space or an outdoor environment devoid of acoustics for the system to really shine. Now, that's not to say we can't use it in rooms that already have some reverberation. It's just that your mileage may vary depending on what your artistic goals are. Certainly, a lot of people use it in theaters and larger halls that already have acoustics issues. And this is just, if you used reverb before, you'll like this reverb too. I'll put it to you that way.
She also had there was another question. They had the same from the same person about, which I think is really interesting. Do you see spatial technology as a possible solution for unconventionally shaped theaters to mitigate conventional timing and alignment issues? If so, how could that help? I think that's a really interesting one.
Yeah, it is. And the short answer is yes, as long as your spatial technology is processing with delay as well as level. Yes, I think being able to delay things in this multi-dimensional way really eliminates a lot of the problems we've had in the past. I think this is really good. I wish I had kind of an example to show this, maybe. Well, that example of in the round with surround speakers, how else would you distribute that signal, especially if a sound had to move in real time? So that fixes timing issues in a way. And yeah, we see it in fan-shaped churches or any fan-shaped room, anything played extra wide. You end up in a situation like the slide we showed with 4 line arrays. Usually you would route this, the signals the arrays would receive would be like left, right, or mono, left, right, mono, or something, and the timing is going to be wrong. Do you want all arrays pointing straight out, which creates more timing with an acoustic source, or do you want them to fan outwards, which is good for the acoustic source, but now you have a higher probability of seams and coverage? You know, I would say live sound is the art of scientific compromise, and this has been our job in the past, but now let's just let the processor do it for us and just kind of sprinkle the room of speakers and let it do the math. Yeah, I think it's really interesting. It's funny because, you know, we talk to a lot of people. We go, well, maybe you want to consider a DS100 for your project. And they go, oh, I don't need any sound to come from behind me. But of course, that's not really what this is about. Being able to move sound around the audience is just as added benefit. It's easy to do once you have positional based mixing. It's really about fixing timing issues, like you said.
Here's a question from Daniel. Can you adjust an object's directionality so a more directional source will have a more directional perceived spatial image and it falls off faster as you get off axis?
I think this would refer back to the spread control of a sound object, as well as its relative position. So one of the examples I use is we talk about spoken word presentations. Is I really like this idea that if I was speaking to you from stage, I could walk all the way to the downstage edge, and it essentially will narrow my image to make it sound as though I'm addressing a smaller percentage of the audience. It allows me to look at people and talk to them. And then as I back up and address the room, the image becomes larger. And you can control this artistically using the spread control as well. I think this is a really powerful presentation tool that just isn't possible with current PA systems. So hopefully that answers the question. Whether it's done by object position or augmenting the spread control is up to you.
Here's a question from John. It says, is there a figure known for the max speed that you can move an object without experiencing that time glitching?
Unfortunately not, because it's content specific.
Yeah, it's depending on the frequency response, it might be more noticeable of what, I mean, if this is a big low thunder thing that's moving around the room versus a fly, it's going to be, you know.
Yeah, I think in general, the more that the tone is a sign signal, the more it'll be susceptible to audible artifacts. We've seen this even with, you know, kind of soprano singers. If they're really holding a consistent note and you move the object, you can hear it stepping, in which case we would switch the object to off mode as its delay function, even maybe just temporarily for that one gag and then put it back into full mode afterwards. But yeah, it's really content specific. It depends on the distance of the object from your loudspeakers and how fast it's moving in relation to other loudspeakers. There is no easy way to measure it or predict it at this point. What I will tell you is me and Drew, we were kind of like the two main soundscape guys out of the US office. Drew's based in Manhattan doing Broadway stuff, and I'm doing all the rest. Neither of us have ever been in a position in a real show where we felt like we had the issue and we had to switch the object mode. We have it all the time when we're doing gag stuff and demos and flying sounds around the objects in demo rooms and that kind of stuff, but never for a real show on a full scale has it been an issue. Your mileage may vary.
A couple of questions about kind of operating, you know, soundscape specifically. A question from John: are you able to place the venue image behind an operational interface?
Yes, correct. You can scale an image on top of a positioning beam in R1.
Yeah, and here's a question from another John. What function groups would you be using in the round setup for your loudspeakers?
There's a couple of different ways we could approach it, but generally speaking, I would have all of the main speakers that are in the middle pointing outwards as a main function mode. And I would have all of the outer speakers that are pointing inwards as a surround or 360 function mode. It could also be a second group of mains function mode, depending on the particulars of how you want the system to behave. It's a good question, though. Another good question I saw here is, can you use these technologies with older D&B loudspeakers? And the answer is yes. Truth be told, you can use these with any loudspeakers. They work best with very well-behaved, high-quality premium loudspeakers made by D&B Audiotechnik. But It can be used with any type of a loudspeaker, particularly if you have ceiling loudspeakers or some type of a special format loudspeaker that isn't made by D&B, that's acceptable as well. And if you have older legacy speakers like Q series, C series, etc., older loudspeakers from D&B, those can now be chosen in array calc. You may not be able to predict them, but they can be picked as a speaker type. That way that information gets transferred into the DS100. So yes, we made it backwards compatible with all loudspeakers ever made in the history in the 39 years of D&B audiotechnik. Yeah, that was a good question from Craig. Yeah. Oh, my buddy Nathan down in Brazil chiming in. Let's see here. How do you set or configure the soundscape system in a wide venue to do a corporate event, for example? Maybe soundscape is not the best option in that case. You know, I'm going to make a blanket statement because we're not looking at a room diagram together. He knows where to find me, and he knows that I'm always down to review designs with him. But I think this would be a really good application for soundscape, as long as our speaker deployment is taking into consideration the overlap between adjacent loudspeakers. Very wide rooms are a timing nightmare. There is no winning. It's just giant phase smear. And your only choice as the operator, the designer, is where you put that phase smear and how you put that phase smear. And I think soundscape will alleviate a large portion of that. Maybe not fix everything, but definitely make it faster to deploy, better sounding in an easier way. This is great, you guys.
Let's go through a couple more real quick, Nick, that are on the same topic. Here's a question from James. Says another system calculates the time difference and then adds 10 milliseconds for precedence effect. Does D&B do that, or precise alignment?
Yes, it's a good question. So the idea of precedence effect, for anybody who is not familiar with it, it is a concept that you can redirect localization through multiple arrival times to the listener. So let's say hypothetically, I have a speaker up here and I have a speaker up here, and you are the listener. I can put the same signal at the same volume between both loudspeakers, and by default, you will perceive the sound as coming from me right in the middle. But as I change the delay going to one loudspeaker or the other, you will perceive the signal as coming from whichever loudspeaker arrives to you first. This is called precedence effect. The truth is, what happens in the processor is our what did David Haskell call it? Black voodoo, German magic. Yeah. And naturally, precedence effect is happening. This is one reason why we like overlap between loudspeakers, because you're getting multiple arrival times and you're localizing to the earliest arrival time or a combination of arrival times. This is how we can ghost an image between loudspeaker positions and have it work across a larger area because of the overlap between loudspeakers and the precedence effect. So it's happening automatically anytime we do even precise time alignment to the acoustic source. Precedence effect is happening inherently as a fundamental concept of what's happening.
Here's a question from James. Do the calculations take into account the height of the listeners and height of the loudspeakers?
They do not. Soundscape is currently working, I mean, object-based mixing part of Soundscape is working on a two-dimensional world. So it sees everything at the same height. This is always a good question that comes up because it turns into a mind bend, particularly if we're used to thinking about PAs in a traditional manner. So if we use the example of, I love that we're doing this right after we talked about precedence effect. This is great. We have front fills right in front of us, and we have mains high up in the air. We would need, in a traditional PA, to delay the front fills back so that the time arrives at the listener at the same time as the mains, right? This is to avoid multiple arrivals and to avoid comb filtering. However, in Soundscape, we don't want to do that. If we delay the front fills back, we will then be breaking their time alignment with the acoustic image coming from stage. So we're already introducing a negative side effect with this new way of looking at PA systems. And with precedence effect, will be localizing to the front fills first because their arrival time is first. And getting multiple arrival times later is already what the system is all about. It relies on that. So let's just let it work. Yes, there are situations where we'll find that we might add some amplifier delay to compensate for extreme situations. This has to be a decision made on site based on your artistic goals, just like we always used to with the PA system. But the vast, vast majority of soundscape deployments don't require any delay. We let them be in wrong timing because of the vertical offset, and this actually plays in our favor with localization, especially since we're getting multiple arrival times from everywhere already. So let's just accept that as the new norm for this type of a sound system. And I know it's a weird concept. I like where your head's at. This is always one of the first questions we get from a high-level sound designer, and all I could say is let's figure out how to get you in front of a soundscape system so you can experience it.
Here's a question from Stephen, which I think is kind of it's funny and interesting. He says, so we're using a soundscape system. We're in love with the spatial balance and ultimately the experience for the live performance. The problem is I have to send a stereo mix to the video guys that gets recorded and then given to the artist for review. How is this handled?
Yeah, I mean, we can bus out mixes from the DS100. That's no problem. We can bus out mixes from the console. There's nothing to stop you from running another submix, or maybe reutilizing your stereo bus for your record mix, and it never goes to the PA. And nothing is ever going to reproduce the experience in the audience, unfortunately. Just like Zach talked about with the example of recording the choir, it doesn't matter how good of a job we do recording it. Once the spatial information is gone, it's gone. And that can't be restored back to the listener. So yeah, I mean, when you give your board mix to the artist for review, it's going to be missing that. This is a new hardship. I don't know if it's really a new hardship, because who's to say that your board mix sounded like it did coming out of the PA, even with a traditional PA? But it's yeah, I think it's a consideration. Yeah. So hey, maybe you put a binaural recording head mic in the audience. Maybe that's a good way to do it instead of a mix off of the board. No. Or maybe you take all of your object positions and you pipe them into a Clang processor and use that as the way to play it back to the artist. I mean, I know it's absurd, but yeah, these are the new problems.
They just put 5 little E5s on the bus, amp and a processor.
I mean, that is a really good point. If you take an existing show with existing object positions and you swap the PA deployment out, you can play back that same show. It will re-render in real time to a new variation of speaker positions and re-render as best it can based on what loudspeakers are there. So this is why we see it. It's really handy that you can do pre-production in the shop or in the office with, like Zach said, 5-inch loudspeakers, and then bounce it up to an arena with 38 loudspeakers all around you in a circle and have an approximation of the same experience. Obviously, there are lots of variables like acoustics that will change the experience, but you can do pre-production, or you can go from venue A, where maybe you could do surround speakers because you did production rehearsals there, and then the tour picks up and goes to venue B, and you don't have the time or the budget, or you don't have the hang points. You can convert your show automatically by eliminating the surround speakers into a forward-facing only show. The processor will up-mix this, or down-mix this in this case, to the new speaker deployment. That is a key benefit of the processor knowing the speaker positions and doing the rendering in real time. We can swap out the speaker positions, the quantities, the models, and have it re-render for the new available positions.
Yeah. Here's a comment from Dominic. He said, we played with a binaural head and soundscape. It does work surprisingly well, audience noise withstanding. So maybe you put them in a nice little isolated spot. And
I would tell the audience on your binaural head mic to be quiet.
Honestly, Dominic, that support.us address is in there. I would love to hear some of that. It would be amazing.
Yeah, I really would too, actually. I have not actually heard that used, and I'd really like to hear more about your experiences and maybe even a recording if that was possible. So yeah, support@bbaudio.com or support.us. dbaudio.com.
We won't share it with anyone. Couple more questions here, and there was a couple of kind of product suggestions. So if you put in some suggestions here, we won't necessarily read them all, but we will definitely take them to heart and take them back to the R&D guys. But there was one of them was from Daniel, said I'm working on any 3D version for say theatrical situations where I have height on an effect and not just depth. I think you kind of touched on that a bit.
Yeah, I think you know, I think we're still in the early stages of spatial audio and object-based mixing, and at least to get us started and our head around this new paradigm, I think it's really important for us just to capitalize on the fact that our ears are spaced this way, and therefore we get most of our localization in the horizontal plane, and this is really effective. At some point, and in certain applications, vertical panning is also important, and for sure we're looking into that. The math is easy. It's an issue of interfacing and keeping it usable and making it work in a touring application and all of that type of stuff. So yeah, keep an eye on our clever Germans. They're always thinking about stuff.
It was a question from Kenneth. He said, if I choose to time align my mono vocal system with R1, so using the channel delay, does the DS100 Soundscape calculate any of these values around the delay settings already in R1?
No. I think what he means in R1, what he's saying is changing amplifier delay times, which is our traditional PA is set up, right? Using R1 to control the processing that's within the amplifiers to be able to push our front fills back in time and do delay for our delay speakers, et cetera. Soundscape, the DS100 is not currently aware of any variances in latency happening downstream of the processor. So yeah, will not compensate for that.
So the real
what I would
answer
say
is,
in that case is use a matrix input, and at every matrix cross point, you can actually distribute the signal with a fixed delay time to every loudspeaker separately so that you could time align that input manually and then have sound objects working on the side. That would be a way of moving the processing from the amp channel into the processor, and now it won't affect the rest of your show.
yeah, there's kind of some, depending on your situation, things you could do there, but probably not the time.
Yeah, I mean, to be super clear, the DS100 has a delay setting at every matrix cross point. So you can delay an input to every output separately if you wanted to.
Yeah, you see the list there, Nick. There's a few questions we didn't get to that are kind of similar to some of the other ones. So I think we covered the concepts, but any of those other ones that you see, I mean, we talked about how you could use some older loudspeaker technologies with this. It's kind of backwards compatible. That was a question from Craig, and then you answered that one. Sorry. Oh, and John said a plugin for Vectorworks would be really great, so we'll take that to the R&D guys.
I'm with you, John. I come from a lot of big corporate audio background, and we're 100% Vectorworks in my background. So yeah, I'm with you.
Here's an interesting question from
wait, one quick thing. I just wanted to point out, just so you know, you can export the speaker sources from ArrayCalc as a DXF file, which is importable into Vectorworks. So you can get your speaker deployment into someone else's Vectorworks program. You just can't get the Vectorworks venue into ArrayCalc yet. But I'm with you.
This is a question from Daniel. He says, what is the best way to determine where the quote audience is? In a traditional configuration, setting delay times is sometimes as much about aligning a delay speaker to a main speaker as it is figuring out where the alignment point wants to happen, as the relative distance can change based on the listener's position.
Yeah. So Ralph Zulig is one of the clever Germans I keep referring to, and he's one of the great minds behind Soundscape. And when he first started teaching us internally about this new concept, he brought up this idea of, you know, no two of us as professionals will time a PA the same way. And in fact, I as a professional will probably not tame the same PA the same way twice. You know, it might depend on my mood that day, depend on how many drinks I had the night before, depend on whether or not I got in a fight with my wife that day. I might be all down for perfect timing and that's it, or I might be intentionally breaking some delay times to redirect localization. This is a new way of looking at it, that you're trusting in the processor. And this idea that you're not making the judgment calls yourself as a user is both powerful and scary. On one hand, it's equalizing the way sound systems behave, which I think has benefits to our industry in general. On the other hand, it's taking away some of your decision-making capabilities. I mean, not that you can't just add delay into an amp channel and kind of break or do, whatever your magic is anyways. But as a concept, it's scary, I know. And so back to the question at hand, you don't really need to dictate a listener position as long as every listener can hear multiple loudspeaker positions at the same time. Because we're reliant on the overlap of coverage, it's working everywhere. This doesn't mean that we don't have to consider the vertical tilt of our speakers or the splay angles, etc. But when it comes to timing between loudspeaker positions, we typically just trust the processor. Of course, there are exceptions to that, but yeah, it's a tough one. I know. I've been working with Soundscape for a little over 2 years since it was released, and I still have a hard time figuring out how to like really communicate this and explain it. It's just different. What else? Did we get through these?
Oh, a couple more questions at the end. Do you see those?
Oh, killer. I was going back to make sure we didn't miss any. Would a Dolby Atmos mix translate into Soundscape? Theoretically, yes. But, and the buts are a long list, and I have to admit that I don't know enough about Atmos deployments to really be an expert on this topic. We've had conversations with Dolby about this. It is theoretically possible, but getting us to speak the same language isn't as easy as one might expect. But D&B loudspeakers can work on an Atmos system, and the DS100 could work as a matrix mixer. So if nothing else, yes, they can coexist. Getting our object-based mixing to run in tandem with Atmos is maybe a more complicated answer. But let's put that under the category of, let's talk about your project, what you want to achieve, and talk about what's possible. And if we need to, we'll pull in some of our friends from Dolby so we can all be one happy team and talk it out. Support.us@dbaudio.com is a great way to start that conversation. Please tell the home office to make your rigging available in DXF downloads. I spend half my time trying to draft accurate rigging in crowded light grids. Drew is sick of my send yoke emails. Yeah, I know what you mean. Yeah, I think we're getting better at having all of the drawings. We've recently also gone to support the Revit format of architectural drawings, which has absolutely every loudspeaker accessory known to man available. I know some people love Revits and other people aren't using them yet. But yes, I'm with you. To make the hardware drawings more available on the internet. The Revit ones are available on the internet. If you need a DXF of a particular hardware piece, you're going to have to email one of us to get it, at least at the moment. But message received. I'm with you.
Yeah.
How are we doing on time? I mean,
Well,
we're getting towards the end of our block, right?
Yeah, we are. We're over a little, but we're connecting, and that's really all that that matters. People are engaged. A lot of great questions. As we were talking about when we were putting this topic together, I gotta say you hit every spot that we talked about prior, which is how do you take something that is truly virtual, that would normally be in a very physical location to virtualize and make it virtual, which you guys did a really good job. It's one would think that virtual ideas are much easier to understand in a webinar, but sometimes I'm realizing more and more as I'm not in the room how much I want to be in the room and hear it and go, okay, I'm going to try that. Yeah. And you did a really great job of taking something that is a pretty complex. There's a lot of math going on, and trying to distill that down. I would really challenge everybody to go back and watch it again. Obviously, the emails are up here, so when you have those questions, especially like the Atmos one was very interesting to me, because one of the challenges is, how do I take something from a post house setting and bring it into a venue that isn't a theater, right? And how do we take, because one of the things that we didn't get into, which is kind of a webinar all to itself, is creating content. It's you have to have the system to deliver it. And then once you have that, you have to be able to then create additional content. What we talked about today, the content was the stage, right? The Atmos discussion starts bringing in that whole idea of, okay, now here's everything that was recorded prior, right?
Yeah,
or
right. Yeah, on a large corporate. Imagine the conversation where you're explaining to the video department, you don't want them to mix down the audio anymore.
Right.
You want them to stem it out to you so you can position.
I want a lot of channels, right? Something we love about Dante, something that we love about networked audio, right? Much easier to move lots of channels of audio around. But that is something that, I'll just throw that out there for your team to ponder. I think that'll be a discussion at some point that we'll want to have with a lot of different stakeholders, is creating content, and who, the what, and the where, and the how, the deliverables, all those just behind in front of the processor, we'll call it, right? Upstream of the processor, all these things that need to push into there, the routing to the matrix, the groups. I thought it was awesome. We, like we've always said, we probably cause more questions than answers on every one of our webinars, and I'm kind of proud of that right now. That's something that I think in the world we're in, the opportunity is so great. Please continue to connect up with these guys. Thank you, Nick. Thank you, Zach, for a really well-designed presentation. You kept saying everybody wants more slides. So if you end up doing a little different deck, send them on to us. We'll put them on our website with everything else. But thank you again for this.
Thank you, guys.
And Pete, you got something to throw in?
Yeah, I thought it was absolutely fascinating. This is the ultimate easy computer controlled of all the delay things that are going into your head. And Mac and I worked on a show in 1980, building a delay system for Chris Chaffee for Studio 8H at NBC. They were having a concert there, and they wanted to have Philharmonic acoustics.
The New York Philharmonic.
New York Philharmonic, right.
Who had played in Studio 8H in what,
Way
the
before.
1930s with Leopold Stokowski?
Right.
So it's just a local band, just a little local band.
Local band.
And they were coming back to 8H, being conducted by Zubin Mehta. And he heard the acoustics and said, "We cannot play here."
So it was a custom delay thing. I think it had 50 outputs.
It was 75.
75 outputs. It was in a rack this big. It was all custom electronics. And all it did was control delay to little tiny speakers, not very big speakers, shooting at the back of the audience. And the effect was amazing, just turning it on and off. Immediately, you felt you were in a big room. But obviously, that's extremely simple compared to what you're doing, and doesn't take care of all this stereo imaging stuff.
And trying to keep the deployment simple so it's not a production burden is the other
Well,
side.
this was a one theater, one time design for hundreds and hundreds of thousands of dollars.
Yeah.
Well, you know what I think is interesting is as we come back from this quarantine state, are we going to see more outdoor concerts with a little bit more social distancing? And is this something that can bridge the gap of the concert hall and the new paradigm, whatever that might look like for us?
I think that
Interesting.
everybody will have to, they'll come out with not only masks you have to wear, but face shields, and everybody has to wear a 6-foot diameter hula hoop that keeps them away from everybody. So it just automatically controls the positioning.
Yeah.
And then in 1990, Peter Wexler designed the Carlos Mosley Music Pavilion, which was several trucks would just fold in and put out, and a union crew could install in like 3 hours, and it included like 30 delay towers. They were all battery operated, wireless, and each tower had speakers facing the stage and speakers facing away from the stage with a full delay system in there to get a concert effect on the Great Lawn in Central Park.
Yeah.
And it was amazing, amazing thing. It only lasted a couple of years, but it was a terrific place for the Philharmonic to come.
Yeah, so
Again.
20 years ago, now fast forward with what we can do today. And to your point, Nick, this is something that almost screams out, why not? Right?
Yep,
Why
yep,
not
yep.
give people that experience?
Yep.
And so we'll certainly be spreading that. And
50 years ago, maybe 60 years ago, my partner, who's since deceased, Larry Estrin, and some friends designed some headsets, just 2 headsets with processing to place the signal anywhere in the sound field you wanted to, left, right, up, down, everywhere. And they got a patent on it. And immediately the military heard about it and took the patent away from them to use this technology in fighter jets, so they could hear. They would be told there was a threat coming from this direction. They could hear where the missiles were coming toward them, and he was never able to make it for the public because the military took it away from him. But really
Well,
powerful.
in the old days, we used to get so much technology from the military, so it's funny to see that flip on its head.
Exactly, exactly. And I don't doubt that. Watch your door. They're going to come and take this technology for their own theater.
Yeah, you know, he must have dyed his hair fresh the last day or two, because I think the chemicals have seeped in at this point now.
Exactly. Well, I was taking a famous politician's advice and drinking the chemicals to try to cure myself. So I'm very yellow inside. Here we go.
Hey,
You know,
before we go, I want to make sure that we
Yeah.
mention that there are a lot of webinars also available at dbaudio.com. So
Yes,
if you do want to
please.
dive deeper into soundscape, there's training available, whereas today was more of a concept. And of course, we're available for questions and answers as well.
Yeah,
Great.
no, that's a great point. And you know, we'll Dave, we're going to work on getting Pete's hula hoops rated so as to be able to use for suspension and deployment of speakers in the future.
Definitely.
So or something else with Peter. But anyhow, to everybody else, thank you so much to everybody for being on tonight, and to all our attendees, thanks for hanging on and being a part of this. And we'll look forward to the next topics together. And as always, stay safe and keep in touch with any ideas. So long.
Bye.
Good evening.
Good night.